Good afternoon, everybody. Welcome to the ntop webinar. Today, we'll be talking about the 2022 implementations and about the future plans and ideas that we have in mind. This is the roadmap. After this short introduction, Tony will talk about NDPID. Matteo will talk about ntop NG in 2022. Alfredo will update you about PF-Ring and the Nbox. Later, I will be talking about new developments. We have a new product to introduce today called ntop. We'll give you highlights about Kafka and in particular also about scripting. That is something new we would like to discuss with you. And finally, Martin will show you ntop and scripts at work. I want to give you now an introduction about ntop NG, but only after Tony and Matteo. So Tony, please get on stage.
So, hello guys, I hope you can see my screen shared. Okay.
Very good, thank you.
So, buongiorno ntop community. Today I will give you a short or a brief overview about the NDPI daemon, or short NDPID. Its name is directly derived from libntpi because everything is built on top of it. So yeah, let's start. Oh yeah, my name is Tony, by the way. What is NDPID? It's the open source project. NDPI daemon it is a set of collection of several applications and scripts. Their purpose is to provide everything you need to capture, process, classify, and visualize network traffic. Whereas the NDPI daemon plays the most important part in this game. It uses libntpi and the pcap for the packet inspection. So the DPI serve daemon is not required, but recommended. More on the topic later on. And then there are like several tools, examples, and user applications for further analysis and visualization. For example, there's like a collecd wrapper. It's just a simple application to print statistics in a way that collecd can understand it. There's a war packet dumper that dumps flows matching certain criteria to a pcap file. For example, you can like dump automatically a flow that is not detected or guessed to a pcap file and can analyze them manually. This is like a simple example of a graphical statistics generated with collecd and RRD tool. So in this example, the collecd wrapper was used together with the collecd execd plugin to generate these beautiful graphs. So yeah, you can see the those spikes are pretty interesting for me. So then I see, okay, I need to take a closer look to the dump pcap files, what happened there, and so on. So now I will like give you a short overview of the history of NDPI daemon. So initially it started as a simple integration example for libntpi back in 2020. So the problem was for me that NDPI reader is not meant to be used as a daemon that runs for several months without restart or any interruption. And so, yeah, it did not work for me because I like wanted to have a daemon that runs on my OpenWRT router, for example. And it has also a high complexity and a high memory usage, at least a higher memory usage than the NDPI daemon. And it is just an example to show some of the NDPI features. So for now, it's so this was my the initial idea to start a new project. And yeah, it evolved from a simple integration example to a daemon or tool suite, which I'm using now. So my goals are, so the NDPI daemon does the obligatory flow classification. It generates JSON strings using libntpi's JSON serialization interface. And it also has to have a low as possible memory consumption, because the idea was that it should run on a Raspberry Pi as well as on a small embedded OpenWRT router. And Additionally, CLIP can be used to compress long-lasting flows, so they even take less memory, or they even have to use less memory in the RAM. So yeah, the general memory consumption depends on the amount of flows. So it's yeah, I think memory consumption is one of the most important things for me. And another thing is that the idea was to make the daemon independent from other libraries. For example, for now, a minimal build configuration requires only libndpi and libpcap and a C runtime with POSIX thread support. And last but not least, the daemon should run on low memory embedded devices as well as on a hosted server, which it does pretty good for now. So now I'll give you like a short overview about the architecture. So you can see two NDPI daemon instances running on two different network interfaces, and every daemon can spawn several threads, which can be defined by the user, and every thread has their own connection to the serve daemon, and yeah, pushes the generated JSON strings to the to NDPI servd via a Unix socket. And the serve daemon does the buffering and forwarding to all the connected user applications. So they can connect via also a Unix socket as well, or via TCP to receive these serialized JSON events. So summary, NDPI generates JSON events, streams them to the serve daemon, and the serve daemon distributes events to all connected user applications. It's just a very high-level architecture overview. So it's more complex, but it's just very high level for now. And yeah, I'm using a like self-defined message format for all the JSON strings that that the daemon sends to the serve daemon or to the user applications. And it's just basically it's a JSON string, but with an additional 5 digits message length, and there's like detailing new line character, which is, so it was like, for me, it was required to make it human as well as machine readable. That was one of my goals. And so it makes it more easier to read it. If you connect with a raw, with Netcat or something, you can still read the generated events. So now we are coming to yeah, some of the events. So the daemon generates several different events that user applications can process according to their purpose. So in this image, you can see 4 main categories of different flow events, like flow, error, packet, or daemon events. And every category is divided into at least 2 subcategories describing the exact event. So for the sake of simplicity, only the flow events are shown in this image. There's like the new event, which indicates, which indicates that there's a new flow scene. There's an end event, which is only required for stream-based protocols like TCP. There's an idle event if like some flow did not send anything or did not receive anything over a certain amount of time. The flow memory will get freed and an idle event is generated. And yeah, some important things are like the analyze event, which is like important for machine learning and deep learning purposes, and those libndpi related events, like guessed detected, if something during the detection changed, or if it's not detected. And yeah. So what are my plans for the next year? So at first I would have to have Android support, but it's not my highest priority because it's more for myself than for everybody else. Whereas BSD and OS X support might be interesting to support at least OpenSense, but that will need some code modifications. For example, all the ePOL-based event notification. It's something that's not available on BSD. So another thing is like TLS and push support for the serve daemon. What do I mean by that? For now, all the data that is leaving NDPI servd is not encrypted, but together with like a push function with support, it may be necessary to encrypt all JSON events before they are sent to another servd instance over the internet. Another thing is to use machine learning and deep learning to detect network anomalies, malicious traffic, and layer 7 protocol false positives. There's already like a small example available, which does some basic protocol classification using the scikit framework. But that's something I will show you in a few seconds. So plans for libndpi. One of the issues I faced during testing the NTPI daemon in server environments is that in some cases, the layer 7 protocol detection fails. This is especially the case when a protocol dissector uses encoded expected protocol data unit lengths for a successful classification, because this may hardly depend on the used maximum transmission unit. So depending on the maximum transmission unit, a classification may fail because, for example, it's more than like the expected PTU length is received or less than. So this is something where a generic packet reassemble engine could be really helpful. And it's still work in progress since spring of this year, but when I have some time, I will hopefully be able to finish that one. And then I want to like move some code from the NTPI reader to the core library. The data link processing code, not sure if that's possible because some of this code is tied to libpcap. And more important, the layer 3 and layer 4 tunnel detection code. This is something I like want to see in NTPI deal. And I want also to use some false positives that happen in some rare cases from time to time. And I think that machine learning may help out to reduce those. So, okay. Special thanks. Yeah, before I show the small live demo, I want to say thanks to Ivan Nadi for giving helpful code reviews and providing me with interesting information regarding DPI, and especially Damiano Versoli from Garlab for providing the server and test infrastructure that I need to further improve the daemon. And last but not least, Luca Deri and the ntop team for providing all the support emotionally and financially. Thanks. So now I will show you some examples. So for example, this is the scikit example. So I'm using for the sake of time a pre-trained model. You can see that we have like different protocol classes. So we want to like detect.
Tony, sorry to stop. Can you enlarge the font a little bit because it is very small?
Yeah, it's possible. Moment, it should be possible at least. Okay, that's it. Is it readable?
I think so. Try.
Is it okay?
Yeah. Oh, yes. Okay, thank you.
Okay. So this example, this is wrong. Yeah, defines different protocol classes. For example, TLS YouTube, TLS GitHub, and some other classes. And it uses, as already mentioned, a pre-trained model that is saved to a file. And now we're gonna test it and see. Oh, sorry, that was not what should happen. I should use the old file. And now we'll see what happens when I just open. So here you can see the different protocol classes which are mapped to a number. And now I will like open Instagram, and it should detect and predict it correctly to Instagram. No, not that's. And Facebook flows are also there, but it should also be yeah. So now we can see it predicted. This is like what NTPI detected Instagram, and the AI also predicted quick Instagram. So this is like a very simple demonstration how you could use scikit together with NTPI daemon. Okay, so another one is this is like a collect D wrapper, but it's not that interesting. there's like a flow dashboard using Python Plotly. This is like a work in progress, but I will just show you it. So yeah, it's like a more or less pretty web interface where you can see a real-time events or real-time visualization of processed events. So for now, my local network doesn't have much flows active, just like a total of 44 flows, and nothing is midstream. And there are some flows like with a risk set, only a low to medium. And yeah, that's like, and we are pretty, it's not finished, and I need to rewrite most of the code because it's not responsive. So it doesn't have a responsive design, which is pretty bad for nowadays mobile devices. And so last but not least, there's like one of the interesting visualizations or like text-based visualizations is the flow info, which provides me, which helped me a lot during development. Okay, the issue is it's too big, so it's not showable because yeah, it's just too big. But okay, I would show you that, but you can also like test it out on the GitHub. Yeah, using my GitHub repository. So that's basically all. So I'm pretty much done. Any questions?
Hi, Tony.
Hi.
Ziad speaking. So I have just thank you for the presentation. Just one question. As you send all the event from the flow, I mean update, creation, etc. Idle. Do you have an idea about how many events can be handled when you are sending the JSON?
Yeah, thanks for the question. Okay, it depends on some options you can set. So, for example, I can give you. Wait a minute. So the most of the events are like, for example, here can you see the relation of all the events, and so for this example, most of the events are like packet events, which indicates that. So, for example, you can set the NDBI daemon to send the first few packets of a flow. This is, for me, this is necessary to write new classifications, new dissector routine and dissectors and stuff. And this is like, you can set this as you want. You can also disable those events. So without that, I think it's not that much. But I don't have like any statistics. I cannot provide any statistics yet. So, but this is maybe something might be really useful.
The second question regarding the machine learning part, which I'm interested in, do you plan to integrate back this model in DPI, or it's just for exploration work?
So, I mean, that was something I was like thinking of to integrate this into NDPI, but I mean, as NDPI is written in C, we probably, so I don't know any like pure C ML or DL framework. So might not possible, or maybe it's not that easy. So I don't have enough information to, yeah.
Yeah, we should definitively. I will open an issue in order to have trace of it in how to integrate some machine learning part. I think it can help you in your work and even for our future plan in NDPI.
Okay.
Yes, yeah, you have a lot of experience in machine learning. Also, you contributed to NDPI. I think you should steer this development if you want, and to have machine learning better integrated into the library if you want.
Yes, I was thinking about that, Luca. So it was my plan last year, but I didn't have enough time for it. So I will start at least by opening a draft pull request with some guidelines about what need to be done.
Okay, thank you.
Okay.
But it will be definitively generic and not tied to Python because it's the most problematic part. So yeah.
Good. So if you do that, then we can also integrate your DGA work based on machine learning into NDPI as a first-class citizen, because today it's there, but we should probably merge the code in a better way based on your future work. Thank you.
Any more questions?
To my side, I just want to thank you for all the work you have done on NDPI and the patches and the time you spent on it. Thank you again, Tony.
Thank you very much.
It's a pleasure to work with you.
Thanks.
Okay, so this presentation is over. Now it's time for Matteo to talk about ntop. Matteo.
Hello everyone, you should be able to see my screen, right?
Yes, correct.
All right, great. So, hello everyone, I'm Matteo Viscosi, and we are going to take a look at what we developed in ntop in the last year. So let's start, first of all, with the UI refactoring, because we thought that ntop had an old version style of user interface. So for this reason, we decided to renew it, and by using the Vue.js framework, we decided to refactor the user interface, by adding even the possibility to add differences between charts, etc. So let's jump to ntop directly so I can show you it. This is currently available in the last ntop version, in the dev version, and we are planning to release it in the next stable version. And as you can see, we reworked the entire graphical user experience by adding the possibility to add confrontation between charts. For instance, let's see video. And here you have multiple time series in the same charts, or multiple time series in different charts. In this way, we developed these in order to enhance the ability to analyze the traffic and see which are the problems in a network and which not, and if everything is going right or not. Other than the UI refactoring, so all the things about the charts, etc., we decided to even develop further the traffic analysis by using the maps that we presented in the latest version with the service map and periodicity map. We decided to develop a new map, the asset map, still to understand which is the situation, the current situation inside a network. Let's jump again to the ntop software, and let's take a look at the maps. So this is the service map, and here we have the periodicity map. The other one is available just in the just give me a second, in the XL license, ntop XL license that I'm going to present later. And it is a map representing specifically the resources available in a network. So just like NTP server, SMTP server, etc. In this way, we decided to develop it to understand in a large network which are our assets in a network. And we decided even to other than adding the standard table version, we decided even to add a new centrality view that we called exactly centrality view, in order to understand how big, let's say, a node is and how important a node is in a network. Other than that, we decided even to enhance the historical flow because, as you might know, we added the support to ClickHouse database in the last two versions, and in that way, we added it in order to analyze again the traffic inside the network and to understand where a problem could be. We enhanced it by adding a lot of new filters, a lot of new data, and the possibility to see pretty much the same data that a flow had when it was live, so when it was still alive. Lastly, we decided again to enhance the traffic analysis because this is the ntop ng software, so a tool to analyze the network traffic. We decided to add a lot of new things, from a lot of new charts or a lot of new checks and alerts, a lot of new data, just like the payload inside the flow that you should be able to see inside the flow, the TLS flow, for example. If we take a look at the ntop directory, as you can see here, you have the payload. This is, we added it in order to understand better what's inside the flow, because sometimes you can understand some information, some extra information by analyzing the payload itself. Other than that, even here we have still the UI refactoring, because we decided to renew the user interface regarding hosts and some pages of the host. For example, the app, the application page of the host. Again, let's jump to ntop ng to take a look at it. Here. This is the new restyling of the app page. Just like the app page, we have even other pages, just like the traffic page, the packets page, and so on. We did this in order to understand better the data we have inside ntop ng. And lastly, we even added some alerts and some tracking about MAC addresses with the device and MAC tracking. A new alert, let's say, a new way to take a look at the devices inside the network, where you have the possibility to add a new exclusion, say, okay, this host shouldn't go idle, or it shouldn't be here. Everything in order to enhance the traffic analysis of ntop ng. And just like I introduced before, we decided to add a new license in ntop ng, the XL license, that currently has the increased maximum number of exporters, increased number of monitored interfaces. In the L license, we had the total of 256 total exporter available. Now we have a maximum number of 1024. And the same goes for the monitored interfaces. In the L license, we had 32 maximum interfaces. Instead, here in the XL, we have 64. And here we are even adding new features we are currently developing in ntop ng, just like the host Sankey, the so well-known, let's say, Sankey charts available for hosts. So in that way, we are able to see the traffic flowing through and from the software itself by understanding even the protocol used, who an host is talking to whom, etc. Lastly, with the latest version, we did a lot of improvements regarding performances. We can see from the version 4.4, so the last year version, we had a thread number by analyzing a single Wi-Fi interface. We had the thread number going through from 50 to 60, with a memory usage of 6 to 8% and the CPU usage going through between 13 and 70%. Instead, in the last two versions, we reduced a lot. First of all, the number of threads. In the 5.2, we have running from 27 to 33 threads. And instead, in the last development version, the 5.5, we have a total of 24 from 24 to 30 thread. And the same goes for the memory usage. We currently use half of the memory in comparison with the 4.4 version, and the CPU usage is a lot lesser, as you can see, from 2 to 6% less. Instead, again, with 4 interfaces, we have a total of thread, again here, running from 38 to 46 for the 5.5 and 5.2 version, to a 60 or 70 in plus with the 4.4 version. And again, the memory usage is a lot lesser, going from 5 to 7%, in comparison with the 12 and 20% of the 4.4. And lastly, in the last version, we even reduced again the CPU usage, running from 15 to 22%. Instead, in the 5.2 version, we had 23 from 23 to 40%, and in the 4.4 version, we had from 30 to 50%. So in the last version, let's say we planned on reducing a lot the usage of the CPU, memory, etc., having better performances. Lastly, let's talk about an edge. Even here we added some little things, just like the support to multi-WAN and multi-LAN, and even the support to VLANs, with the possibility to add and remove VLANs, etc. And even the handling of the HCP service. And this is pretty much everything. We've really fast run through the news of ntop ng with the last two versions. Do you have any question, or we can jump ahead?
Matteo, can you explain what are the use cases behind the service and the periodicity map?
Yeah, sure. Just let me share again the screen. The usage of these two maps is to understand, like I said before, the state of a network. The service map is mainly used to understand lateral movements, because in the service map, you should be able to see the flow running from a local host to another local host. So all the services and talks available between local hosts. We developed this in order to understand, to enable the people to say, okay, this flow is right and this is not. In fact, as you can see here, all the arrows are red because I disabled all the local host communication, and whenever a new or old flow running from a local host to another one, not enabled, is going to pop up in the network. Then a new alert is going to be sent to ntop, from ntop-ng. And we did this in order to reduce the possibility of lateral movements, the well-known attacks of lateral movements. And the same goes for the periodicity map. Instead, here we have communication from local hosts to remote hosts with the understanding of the frequency of communication between these hosts, the number of analysis seen, the flows seen. As you can see here from the table view, maybe you can understand better. We have the number of observations. So for example, here we have my PC talking with this coinanalyze.net. By using TLS, we observed it 222 times with a frequency of 30 seconds. Again, we developed this in order to understand if there is some illicit traffic inside the network, because, for example, a botnet uses a periodic talks between a local host, an host inside the botnet, and the botnet itself. So we did this. We did all these maps in order to understand the state of a network, and if there is some misconfiguration or even some possible attacks going on inside the networks. And the same goes with the asset map, that the asset map instead shows you the assets available in a network. So NTP server, SMTP server, IMAP server, POP servers, DNS servers. And many times we have, for example, attacks where an attackers configure let's say an unwanted host has a DNS or NTP server. So this is pretty much everything about the maps. Really fast analysis.
Thank you, Matteo. Any more questions? Shall we move to Alfredo? Okay, Alfredo.
Okay, hi everyone, this is Alfredo. I want to give you some update about peer-freeing, N2Disk and Mbox. So let's start with peer-freeing. This will be a quick update, then we will probably have some more webinars early next year. So today I want just to show you what we have done the last year, what are the plans for the future. So as of peer-freeing, you probably know that peer-freeing is a capture framework that we developed to accelerate the packet capture in our applications, and it is based on, it provides several acceleration levels based on the adapter model that you use or the driver that you use. So in short, it provides basic limited, let's say, packet capture acceleration when you use it with standard any adapter, let's say, with standard Linux drivers, or it can provide you mid acceleration when used with XDP drivers, the Linux Express data path drivers. When you have an adapter with a Linux driver that supports the AF XDP socket. Or, of course, we have our peer-freeing zero-copy drivers that provide the best acceleration, implementing zero-copy kernel bypass that allows us to cache the traffic up to 100 gigabit. This using supported adapters like Intel or Mellanox, or using FPGA adapters. In fact, we have also drivers for Napatech, Silicon FPGA, Fiberblades, and other vendors. Now, in the last year, actually, the end of the previous year, we introduced support for Mellanox adapters to the NVIDIA. And during the last year and months, we improved this driver, and this is a really nice adapter for a few reasons. First of all, we implemented the zero copy capture on top of ConnectX adapters 4, 5, and 6. And this is able to deliver performance up to 100 gigabits per second or even more, and features nice offloads which are useful in the packet capture activity, like the hardware timestamp with nanosecond precision, the packet filtering in hardware, which is really flexible and supports many filtering on Mellanox, load balancing, which is in practice similar to the Intel RSS, so the ability to spread the load, splitting the traffic across multiple queues and multiple application threads. And also traffic duplication, which is not available on Intel. It was available only on selected FPGAs. It was available on Fiberblades, for instance. But for instance, on Intel, when you open the adapter using zero copy accelerated drivers, you can open the adapter just from one interface, from one application, sorry, because access to the interface is exclusive, because the application takes control over the adapter. Instead, with Mellanox, you can open the adapter multiple times. So that means that you can have multiple applications capturing the same traffic. And you can even use it in combination with RSS, like in this picture. Now, if you look at the Intel adapters that we support, as you can see, there are many families that we support with our drivers. So we still support E1000E and IGB, which are the 1 gigabit chipsets. We support IXGB and virtual functions for IXGB. We support I4E, which is the X710 family. And in the 2 years ago, we introduced support for the E810, which is the ICE driver, which is 100 gigabit adapter that replaced the FM10K adapter, which is now deprecated. So we decided to discontinue this driver development. And we introduced a couple of months ago the IAVF driver, which supports X710 virtual functions. So why this driver is interesting? And talking about the IAVF, because as we say, this driver supports X710 virtual functions. Virtual functions are usually used to accelerate the virtual machine connectivity by creating virtual network interfaces, which are hardware interfaces that you assign to the virtual machine. So you assign a MAC address or a MAC address that belongs to this virtual function, and this virtual function is used by the virtual machine to have native performance when receiving traffic from the network. Now, those virtual functions can also be used on an host on a native system without virtual machines as standard interfaces. And you can usually steer the traffic to the virtual functions using a MAC address and optionally a VLAN, because they've been designed to provide connectivity to virtual machines. Now, what is interesting is that you can enable what is called the trust mode. This is available on many Intel adapters. That in practice enables somehow the promiscuous capture. So this means that on a virtual function, you can capture all the traffic that you see on the wire, not just those with the MAC address and VLAN of the virtual function. And this also allows to duplicate the traffic. So you can have multiple virtual functions receiving all the traffic that you see on the wire. This means that with this driver, we can implement the traffic duplication that was not possible until today with Intel. So I think this is a nice feature. For instance, we can use ntop to record the traffic and mprobe or ntop-ng to analyze the traffic at the same time in the same box using zero copy drivers. And this was not possible until before this driver. Let's move to ntop. Sorry. So as you probably know, ntop is our continuous recording application network to disk. because why you need this? Because in most cases, you cannot predict an event on the network. So if you want to have access to the packets for that event, you have to continuously record the traffic. And when something happens, you go back in time and get the pickup file, so the packets for that event, you analyze it with Wireshark, for instance. So doing a capture on demand in most cases is not an option if you want to analyze a network event. You have to record everything and go back in time. Now, the data retention depends on the traffic rate and storage size. So the amount of traffic that you can keep, it's, for instance, from the last day or last week, depending on the size of the storage. For instance, at 10 gigabit per second, we have like more than 1 gigabyte per second of data to be dumped on disk, which is 4 terabytes per hour and 100 terabytes per day. So you may notice that the data retention really depends on the storage, and we will not, if we have traffic at high rate, like 10 gigabit or even 100 gigabit, we really need a huge storage to keep the last few hours. So during the last years, we implemented several techniques to save space on disk and to be able to enlarge as much as possible the data retention. For instance, we implemented packet compression, but we have seen that on internet traffic, which is already compressed or encrypted, this doesn't save a lot. We have seen up to 5%. On LAN traffic, this works better, but still, we have a lot of data. You can use packet slicing that allows us to dump just the packet headers, keeping the payload, and this saves a lot. We can use BPF filtering. That means that we can dump just traffic matching a specific set of IP addresses, ports, etc. But we have to know in advance what is the traffic that we want to store on disk. So it's difficult to predict what should be the correct BPF that we should use. More interesting is the layer 7 filtering. So the ability to dump traffic based on the layer 7 protocol, because we know that in many cases, we don't want to dump like multimedia traffic that it's most of the traffic, and we probably don't care about that. The same for the encrypted traffic or compressed traffic. So with the layer 7 filter, we can say to enter disk, just keep, I don't know, YouTube traffic, Netflix traffic, or dump clear HTTP traffic, for instance. But we still end up with a lot of traffic to be dumped on disk. So what if our storage after filtering doesn't satisfy the data retention that we want? If we consider that probably not all traffic is alike, because probably we have traffic matching some network event like security alerts and the rest of the traffic. Probably we want to prioritize this traffic, so network events, and make sure that we keep traffic matching network events for a longer period of time, like for weeks, while removing the rest of the traffic to make room on disk for the new traffic. So we introduced what we call the smart data retention. So what we are implementing, and we want to release it for early next year, is the ability to process, for instance, network events generated by ntop-ng. So you process your traffic with ntop-ng, ntop-ng trigger events, alerts, and use those information to filter the traffic on disk. This means that you will have enter disk, capturing traffic from the network adapter and storing this traffic to a first level storage that we call cache. And then we have another activity, which is processing the alerts, the network events coming from ntop-ng, for instance, or other software, and storing in a second level storage that we can call it archive, the pickup data, which is matching those events. Okay, now let's move to the Mbox. The Mbox is an hardware appliance that with our partners we sell, let's say, for those who don't want to bother with selecting the hardware for running our software, installing the software, doing some tuning to get the best performance. So we do all of this for you, and we build the Mbox appliances. Now, the Mbox appliance is using a user interface, which is the Mbox user interface, which is a web interface that you can use to manage the box. That means configuring the networking, like the IP address on the box, formatting the disk, managing the applications, like configuring the applications, like ntop, mprobe, etc. Now, the Mbox user interface that we have today, first of all, it's supported on Ubuntu only, so you cannot use it on other Linux distributions. And it is also based on old technologies. For instance, the user interface, it's using per-CGI, which is a deprecated technology for rendering the web pages. So we thought that it was time to write this interface from scratch. And after thinking a little bit to the best approach and technology, we decided to use what is now a standard for managing Linux servers, which is using a web interface, which is Cockpit. Cockpit is an open source project, which is web-based, like our old Mbox, that runs on most Linux distributions. It's sponsored by Red Hat, but it runs on Ubuntu, Debian, CentOS, and many Linux distributions. And what is nice is that this project, this web interface, can be extended by means of plugins, and a JavaScript API is provided to extend it. And we have seen before that we are renewing, refactoring the ntop web interface using Vue.js. So we decided to use the same technology to extend Cockpit. So we are using HTTP and Vue.js. In practice, we are writing plugins for Cockpit to extend Cockpit to build a similar user interface, similar to the old Mbox inside Cockpit. So I can show you quickly how it looks like. So this is the login page for Cockpit, which has been customized. In Cockpit, you have features which are similar to what we used to have in our Mbox appliance. So you have an overview page where you can monitor the usage, the CPU, memory, etc. You have logs, you can manage the storage, you can manage the networking, like network interfaces. You can navigate the file system. You can manage the box updates, etc. And we are adding configuration pages for our software. For instance, this is the configuration page for ntop, where you can set up the license, for instance, and check the license status, or you can set up the application. So here, for instance, you can select the capture interface that you want to use in ntop, add the local networks, for instance, select what the mode that you want to use for resolving the addresses, configuring an endpoint where you collect the flows from mprobe, etc. Or you can even add advanced settings for ntop if those provided by the user interface are not enough. You can start the service. You can just, using this icon here, you can just jump to the ntop user interface and log in. We just started the development of this, so we are planning to release a fully integrated Mbox based on Cockpit for early mid next year. With respect to the old Mbox, besides this change, this more modern interface, We want to make it more simple for the user. For instance, if you have to configure and probe, we used to have a user interface with many configuration items, which was just the web version of our command line configuration file. Now we want to create like wizards that are based on use cases, so you can, in a few steps, configure your box based on what you have to do without bothering with all the options. Of course, this project is already on GitHub, so if you want to contribute, you are welcome. You will find under ntop, cockpit ntop. So yeah, so thank you. If someone of you, do you have questions? Okay, great. Thank you.
Hi. So as there is not a lot of time, I will move forward immediately and show you the latest development. Okay, that we want to discuss tonight. So tonight I want to talk about three topics. The first one will be ntop. What is ntop? ntop is a software network tap. So it means that it solves a typical problem that people usually solve with hardware. So this means that you have a certain link, a certain host, and you want to supervise its traffic. The main difference between a software and a hardware tap is that hardware tap are usually not very smart. They take everything or nothing, or expensive. They are so-called packet brokers. And in addition, they are complicated to deploy in distributed environments or on virtual environments, for instance, inside a container or on a very dynamic place. So therefore, we thought that it was probably time to create something different, lightweighted, very lightweighted, that we also want to put on very small devices that allows, for instance, to collect the traffic from a remote destination and send it in a secure fashion to a monitoring center. The main use case is troubleshooting, because we want to also to make sure that it's possible to connect to a remote machine and to send traffic to an observation point. And also, we want also to be able to use it in a distributed environment. In particular, we are experimenting with Internet of Things or industrial control systems. So in places where having a port mirror is complicated, because in practice, you will need tens of port mirrors, if not more. So that's why we decided to develop this. And we thought this as a free add-on to the ntop applications. Let me show you in a second how it works. So in essence, there are two components. One is called the ntop remote, and one is called the ntop collector. The ntop remote is a small application that you deploy on the machine that you want to observe. So if this machine it is able to monitor a link, fine. If you want to monitor just the traffic of this machine, it's also possible. We are able to set up a BPF filter so that you can say, send me only those packets that are relevant for me. The relevant packets are sent in an encrypted fashion over UDP. UDP is very important because it's first of all, it's unidirectional, so we don't want to have a return channel back such as TCP. So Alfredo is telling me that the presentation is not moving forward. Okay, now it's working. Yes, let me leave it like this over UDP, and we want to make sure that there is not return traffic that, for instance, you can have in case of TCP communication, because with TCP, you can have, for instance, a hack or something that is going back from the collector to the remote. This is not what we want, because if you're monitoring a sensitive environment, let's say a place where it is not allowed with no mean to interact with the devices, this is very important. The traffic that is sent out by the remote is then collected by the ntop collector. Okay, so that it's one application that can receive the traffic and create a virtual tap interface on the system. So this means that if you have a remote system or multiple remote systems that are talking with a single collector. On the single collector, you will see a new interface, let's call ntop 0, where you can do TCP dump, Wireshark, Suricata, anything you like. Okay, so the topology is sent to 1. Otherwise, another option is to send this traffic to the ntop collector that will forward to Open vSwitch with the VXLAN tags. So it means that you can play with it immediately. This one, it's a use case outside of the ntop world, because as you can see, you can use it with different application development, not by us. Instead, what we have decided to do is to include it without any license, so without any additional cost, without anything more that you need to do after a software update, of course, because this is something we had just released last summer, is to use it with our tools. So in essence, what is possible to do is the following. You can deploy as many as needed ntop remote to your location. So let's say if you are monitoring an Internet of Things setup, you have 100 of devices, you install one ntop remote per device, and you define an encryption key. So in this case, the encryption key, it is very short, and you decide where you want to send this traffic to. So for instance, to mprobe. In this case, mprobe listening on this port, the very same port used by the ntop remote, will be receiving those packets, and then will be creating flows similar to what you will do with mprobe. So in essence, the only difference here is that instead of having a local device, you have a --ntop with the encryption key that we are using. You might wonder, what is the availability, what are the platforms supported? So in essence, we support all the platforms that we support with all the other tools. At the moment, we support the collector just on Linux, but like I said, we believe that this is a corner case for those people that don't need ntop tools, but that need the ability of receiving packets. Because for all the other platform, ntop remote is available, as usual as a standard package. And so that you can put, for instance, your tap on your remote tap on, let's say, previously Windows or Linux, and collect the data on Linux if you want to have the collector, or collect the data on any platform, because mprobe and ntop-ng, where they are available, they are supposed to receive the traffic without any need of having a collector. Just to give you a few words about the performance. We have tested over a 1 gigabit link and reporting you these numbers. We are unable to drop packets up to 400 megabit per second with encryption. Okay, and as you can see, 450, and we see that with encryption we go to 400. So in essence, the penalty introduced by encryption is very little. Also because we are using vectorial extraction on Intel, so this means that it is very efficient. So therefore, we believe that you having the ntop, it's a good thing, in particular for those environments where for many reasons, for money, for topology, or for other reasons, you are unable to receive all the traffic in a single place, so that you can deploy this software that, if used with ntop devices, is not costing you anything, that allows you to collect all the traffic to a central or multiple central locations where you can deploy our applications. I don't want to tell you much more than that, because after my presentation, Martin will show you a demo and will introduce you this tab in practice. Let's now jump to the second topic, Kafka. I think most of you know what is Kafka, but just let me give you a quick refresh. So in essence, traditionally in our tools, we have used 0MQ. That is our best solution for distributing traffic across multiple applications. For instance, one ntop-ng to multiple ntop-ngs, or one mprobe to ntop-ng, and so on. All the topologies are supported. 0MQ is fantastic. It is brokerless, so it means the communications are direct. But we have to say that Kafka is the de facto standard for messaging queuing. So we have introduced Kafka support in our tools many years ago, but we have never thought of using Kafka as a replacement for 0MQ. And this time has come. Let me show you a little bit what are the advantages of Kafka with respect to 0MQ. Okay, first of all, the architecture is broker-based. So it means that you have one or multiple brokers that are implementing some features that are not present in 0MQ, such as, for instance, the persistency, so that, for instance, you can stop ntop-ng for maintenance and restart it, and the broker in the meantime is receiving flows from multiple mprobes and saving them on disk or memory, so it depends how you configure persistency, and send this data to ntop-ng. So this means that you don't have to keep ntop ng online all the time, but you can do maintenance or you can do tweaking, without dropping anything. It is fault tolerant, okay? As I said, this is a cluster. It allows to have replication, and it is very reliable. So therefore, we said we don't want to drop 0MQ because it's very simple. Many people are used to it, and we also like it very much. But we want to also have the ability of adding Kafka in addition to 0MQ for those people that require a complex architecture or that have used already in the company Kafka and they want to use it also for distributing data. So in essence, the new architecture is the following. mprobe is no longer talking with ntop ng directly, but mprobe is talking to Kafka over topics, okay? So we have various topics, and ntop ng is also talking with Kafka. So in essence, what you have to do is the following. So you have to use this new -- ntop ng command line in option, and you will see here that in this case, you will need to specify the address of the Kafka broker or brokers. So this depends on you. So this means that you don't have to specify the IP address of the remote ntop ng, but you have to specify the IP address. The address of the broker. And the same you do with ntop ng. So in essence, you don't specify the mprobe we want to talk to, but you want to specify just Kafka. All the topics and everything else will be configured automatically by our software. As you can see, this new -- ntop ng is also available for 0MQ. So we use -- ntop ng 0MQ. So as you can see, in 0MQ, we speak directly. So mprobe is talking directly with ntop ng. And in case one of the two go down, the communication is interrupted, and then it is restored as soon as they are back. But the point is that they are dropping traffic. In this case, okay, is the broker that can store traffic, and then when ntop ng will be receiving traffic, will receive the new flows that have been put on storage by the Kafka broker. Of course, you can support any combination, multiple mprobes to multiple ntop ngs. Everything is possible. So Kafka, in essence, has been extended from delivering mprobe or CentOS flows to Kafka, also for delivering flows in a special format for ntop ng from mprobe to ntop ng. The last and the most important topic I want to talk tonight, sorry for going so quickly, but we are running out of time, is scripting. So this is one of the things that we wanted to do for a very long time. So in essence, what ntop ng does is the following. So we have an engine written in C++ that is talking with the rest of the world through an API REST. Okay, so these are two examples, Centron and CheckMK, that I used the REST API to integrate our tool with their products. Now, the problem is very simple, that this interface, okay, is designed for speed. It is designed to be efficient. So it means that the engine, it is coded in C++, and then we have a Lua that is slightly slow with respect to C++ that is used for implementing the REST APIs and for the GUI. So this means that the entry ticket to develop or to extend ntop ng is very high, because you must know C++, you must know the internals of ntop ng, so it is very complicated. So this has prevented ntop ng from being really open, because the ntop ng code is on GitHub, but it is not open for people. So in case you have a new need that you want to immediately satisfy, this is not really possible to do, because you have to code in C++. So you need some skills, and this is what we wanted to avoid. So therefore, we wanted to be able to give people the ability of creating, new scripts and new components that can be integrated in very little time, so in minutes, if you will see, into ntop ng. For doing what? For, in essence, for extending the ntop engine in a way so that it is still efficient, but at the same time it is open to do anything. So for instance, if tonight there is no vulnerability, you want to check if your machines are vulnerable to this type of things, let's say looking at the certificate, the signature, for instance, I want you to do it immediately, creating a simple script that you put in ntop ng. So this is exactly what we want to do. So in essence, we want to give people the ability of filling the gap that we have into the implementation, because we want to have efficient coding, okay, something very fast, using Lua, that is a scripting language. So if you want to extend the engine, and we also give people the ability of running some sanity checks, or let's say checks that are not so critical because they don't have to play with packets, but they have to play with behavior. So let's say identify all the hosts that have sent more than 10 gigabytes of DNS traffic in the last 5 minutes, just to give an example. Okay, we want to give people the ability of doing that in a very custom way. So because everybody has a different need or has multiple needs. So we want to give people the ability of doing that efficiently. And also we want to reach some kind of programmability using Python, because Python, like it or not, is the standard language for many people. Okay, there are many developers that are able to use Python. Is the new Bash, if you wish, and there are many successful libraries such as PyShark for Wireshark that are showing that it's a good idea. So therefore, we have decided to do 2 things. Okay, this is work in progress, so the code is already available, but again, will be finalized also based on your input. We are able to release 2 new APIs. So first of all, a Lua API for behavior analysis. So it means that for host and for flows, you can develop new behavioral checks, okay, that allow you to do things that were supposed to be implemented in the past in C++. So for instance, in the host API, every minute we can call a script that allow you to check, what's happening. And the flow API allows you also to execute a function. So whenever, for instance, a flow protocol detection has been completed. So you might say, but we used to know Lua. So Lua was not efficient. That's why we moved to the C++ as an engine. But in this new way, this new design, so we have created, let's say, nano-sized Lua API calls. So it means that the API calls that are made by the Lua interpreter to the C++ engine are very small. So for instance, they will check just the minimum amount of information that is necessary for them to carry on the task. So therefore, they're efficient. I will show you that in a second. Let me show you an example. So you say, I want to send an alert, okay, trigger an alert, whenever the traffic of a host sent, okay, is exceeding the traffic that has been received, okay? I want to send an alert, score 100, with this message. So this is a simple script, okay? You take this script, you put it in this location, so soon we'll provide an editor inside the ntop so that you don't have to touch the shell at all. Okay, so a simple and super custom, alert. It is meaningful, I don't know, but some people need special things. So this is just an example. So just to give you an idea, I took the oldest CPU I have, so it's from 12 years ago, and this script, okay, executing this script, okay, that again it is executed per minute, takes less than 1 microsecond, okay, per host to execute everything. So this means that you can pay this ticket. Okay, it is very important because even if you add a certain overhead, okay, of let's say 1 second over tens of thousands, hundreds of thousands hosts, this is basically nothing because this is called every minute. So we have time for that. Okay, this is very important. And the result of the script is to trigger an alert. So as you can see here, so we are triggering a simple alert based on this condition. And those alerts are first-class citizen, are standard alerts that you have in ntop ng already. So this is the Lua part, is the one that is run inside ntop ng. And we have to use Lua and not Python for a simple reason. First of all, because we already have the Lua interpreter inside ntop ng, and because Lua, it is super efficient. Again, I want to show you again the numbers with this nano API implementation we have done. That is less than 1 microsecond per script, not per call, per script, per whole script. Python does not reach this level of speed. So therefore, we said, let's stay on Lua inside the engine, and let's move to Python outside. Outside for doing what? In essence, for using ntop ng as a source of information. As I said, there are some people like Centron that is already using ntop ng for creating some information, minimum information for monitoring and extracting through the REST API. But this is not programming. This is good for, let's say, web developers. Instead, we want to give people the ability of doing that from Python. As I said, it's a very popular language. And in particular, we want to give people also some stubs, some scripts that they can use immediately for doing custom monitoring tasks, or even for receiving data and creating a PDF report with the data that ntop ng has created. So if you want to go to the ntop ng GitHub page, you will go to ntop ng/Python. You will see that there is this REST API, okay, that is wrapped with Python code. So it means that ntop ng will be talking using Python. Sorry, Python will be talking with ntop through the REST API that you don't see. So in essence, you will see Python objects, Python classes, and then you will play with Python, no REST at all. But this means that our API, Python API, is put on top of the REST API. This because whenever we create a new API REST component, this is immediately available in Python. Okay, and we don't have duplicated code. Python it is just a wrapper for this purpose. Let me show you an example. This is a Jupyter notebook. Okay, so it's a simple notebook that you can find in GitHub in the Python directory. So as you can see, those who are able to play with the Jupyter notebook can immediately put the code here and have immediately executed. As you can see, this is an example of a query. So give me the top remote ports, okay, from a certain epoch to a certain epoch. And this one, it is immediately executed. In this case, it is executed inside the Jupyter notebook. In the other case, it's executed, from shell as a Python code. So we have packaged everything with pip. So if you do pip install ntop, the API will be immediately available to your world. So as I said, we are still working this implementation. At the moment, we have 4 classes in addition to the ntop used for communication. The class that allow you to play with host, with flows, with the interface, and with historical. Historical means that you can interact with time series. So let's say, give me the time series of the score that a certain host did, or give me the last alerts, okay, of a certain host, or create complex queries, as you can see here, playing with SQL in essence, that allow you to extract this data. So just to wrap up, this is something that we want to introduce in the next release that we want to introduce in next quarter, so beginning of 2023. We want to make ntop fully scriptable and versatile because we believe that there is a need in this market of people able, as with Wireshark, for instance, to create and to code a Python-based application that are efficient simply because they are talking with ntop that is already there. It's working maybe since months in your system that allow you to create, to be the information database or the data lake of your data. Today, this was a super quick presentation just to give you an highlight of this new API, but we want to have some vertical webinars in January and February that allow us to go very deep, okay, to programming, so to show you how exactly this thing work, or to other features such as those presented by Matteo and Alfredo. A very important thing is that we plan to put some money to develop, to contribute to our tools. As I said, if you need some support, and if you want to develop open source with our tools, so this is not a job. I mean, if you want to apply for a job at ntop, you go to our website and you apply. Here we're talking about open source, okay? So if you want to develop and extend, for instance, this Python API, create something on top of it, or develop something that everybody can benefit, such as what Tony did, and you need some economical support, we can do as much as possible, but please contact us because we want to grow this community. We want to make sure that this community is growing year by year. And finally, this year we are organizing at the FOSDEM 23, that is the largest open source conference in Europe, the Network Dev Room, February 4th and 5th. So if you plan to be there, we would like to know you in face. So if you want to speak with us, it would be nice. So we are really open to listen to you and to your comments. I'm done. So I don't know if there are some questions for me tonight.
Just a technical question, Luca.
Please.
Regarding ntop, Lua, and Python performance stuff.
Yes.
Did you consider at some time using LuaJIT instead of Lua, as you have the Lua interpreter now with ntop, but LuaJIT is just-in-time compiler of Lua, so it can bring some performance gain. Just in general.
Yes, I see what you mean. We have used LuaJIT in the past. Actually, there are also other sort of Lua dialects that allows to accelerate that. We have removed LuaJIT years ago because it was not completely maintained. I checked the website last month again, and I see that this project I don't want to say it is on hold, but it's not super maintained. So I don't know. As an option, we can probably add the ability for people to use LuaJIT. But at the moment, I don't want to jump back to it without having clear if there is somebody that is really continuously maintaining the software or not. Even though, as you said, you're right, it is much faster.
Thanks for your answer.
Anybody interested in contributing to this code or willing to do so? So
Yes.
let's leave. Please.
On my side, maybe on the packaging part, as I can see how you did with PEEP stuff, and improve at least the way it's built and publish it. Maybe to publish automatically to PyPy, because I saw that you said that you will publish from time to time, but maybe
Yes.
we can build that with GitHub Action as we did for
Yeah.
other projects.
That
This
would
is
be
how
good.
at least when you put a tag on ntop ng, it will trigger automatically the published stuff.
Okay, so please, yeah, if you want to do that, you're welcome. And again, if there are some students, somebody who need economical support for our open source tools, please contact us and we'll do our best to support you. Okay, Martin, I think it's time for you to take the stage and talk about your tools.
Yes, thank you, Luca. Let me see. Slide should be up. And if you hear me, then I can start. I don't have a demo. I have to disappoint you in the beginning, but I have. I just go through the beginning very fast because we are running to the time. So why the ntop is so interesting for us is because I can use it in the industrial environment, and as Luca pointed out already, it uses UDP, so I can ship traffic from like, let's say, more secure or more a network which should not be touched from outside. I can ship it outside and analyze the traffic outside of it. And also there's a smaller use case, but also very interesting, is to use it in the lab for having different security monitoring products aside and to make sure that they receive the same traffic to analyze. So the only here I go through very short. Let's say the challenges we have today in the industrial environment is that many devices want to talk directly to the cloud or somewhere outside, and that goes against like the air-gapped network, or like the network which is just talking to the items itself. So that is one direction we see, and the other one is just in general, besides the IT network, the OT industrial network really need to be monitored as well, even if they are like closed up and no access. That's why the ntop with the UDP, encrypted UDP, is really helpful. So another difficulty in the industrial world is you have many distributed, let's say, physical locations, and you have many devices also distributed. It's not like the where a server center where you have all your servers on one place, and then maybe you have two locations. And in the industrial world, you have many machines, let's say, in different locations, or in the electrical distribution area, you have many these called substation, where you have like internal traffic, but then also traffic which goes outside. So the use cases, like modern PLCs, they are now coming nicely with two web interfaces. They are web programmed, or like you have a web interface and access. And from performance, it's ARM based, so similar like a Raspberry Pi, the 4 Raspberry Pi 4, maybe with 2 GB of RAM. But of course, you have no SSS access, so the the supplier or the company doing this type of devices, they do not give SSH access, but in this case Docker is available. So with that I can pack my ntop remote, the remote part, into a Docker container and listen on one network interface to the traffic going in and going out of this device. So like I tried to put it here as an example. So on the device on the right side, that is my PLC. I have the Docker container running, and it is shipping the monitor traffic to, in this case, a virtual environment where I have one interface and collecting the traffic, and then the ntop collector is running inside the virtual machine where ntop ng is running. So this is very helpful because with the filter I can set, I only check for the traffic. I put that here. I only monitor traffic which is per se not good. So for example, two PLCs talking to each other. In most cases, they do not need to talk to each other, so I can put that in as this traffic I want to monitor. Or if something is coming from outside my normal client server traffic, I also want to monitor that. So that is very helpful. And actually, to connect with what you said for the user script, that is also very helpful here to have this user script, because one use case is actually to monitor traffic not intended for this type of devices, or for example, when vulnerability is getting out, and for older devices, telnet is still on. So I want to monitor and trigger an alert if telnet is detected to any of these boxes. Because in most of cases, I cannot do maybe some firewall rules, because there is no firewall. So I really need to rely on the monitoring to see if something is coming which is not okay. Then I trigger an alert, and I also call them like high fidelity alert, because when I have this user script and it is telnet, connecting to this device, I'm sure I have to check, because that is not intended, and it should not be like that. So I'm very happy about the user script as well. And the other use case that may be a bit particular, but when you have different network monitoring systems, and you want to compare how they are working, then you need to make sure that they receive the same traffic with this in the same time. And for example, with VMware, this is a bit tricky. So when you install the ntop collector on the host, then you can use the ntop interface as a normal network interface and distribute to the different virtual machines. So here the ntop collector is not running on the virtual machine where ntop ng is running. It is running on the host, which is running the virtualization software. So also this maybe in some use cases for that, but at least in the lab environment, very useful. And if I go back, I think for the Docker, that, as Luca already mentioned, outside industrial world, this is also an interesting use case. Or if you have a Windows host where you need to monitor also in virtual machines, then it's also very helpful. So that's it.